So I've been at Dell EMC 7 years. I love Splunk, but I love hardware more. No offense or anything. I like the flashy lights and the fans blowing in my hair, or in my beard, I should say. I founded the Splunk Ninja team at Dell EMC about 3 years ago, or about 2.5 years ago. There's a bunch of them in the room here, most of the dudes that are the Dell EMC folks. They've all been trained by Splunk, Splunk SE certs, at least, some of them all the way up to architect. My background's actually in applications, so I spent time in Oracle and SAP consulting prior to joining a hardware company. It felt really wrong to go into hardware, but once I did, I was like, ooh, this is cool. Educationally engineer, and I have an MBA. I'm also excited to announce that we have I've had a blog for about 3 years called bigdatabeard.com. It's not commercial, corporate thing, it's things that we share opinion pieces, and it was mine at first, and then it became a mashup site for a bunch of other engineers that want to talk about Splunk and Hadoop and big data stuff in general. And we actually just launched our podcast, so you can check it out at bigdatabeard.com. It's in iTunes and in Google Play. It's really focused on that marriage between the IT operators and the practitioners doing things in big data and the stuff in between, which is mostly the context of this presentation. Oh, and these are pictures of my beautiful family. I do travel quite a bit for work, and I try to take them with me if possible. So they're, my 3-year-old has officially spent 10% of his life out of the country, which is kind of fun. Okay. So this session, it's the first time I've done an advanced session, which is exciting. Not that the content is that much more advanced, but that Splunk put me here. But I'm going to have some very strong opinions about sizing best practices on how do you size a Splunk deployment effectively. What we want to talk about in terms of sizing is the things that you can do from a Splunk configuration perspective that can have pretty significant impacts on the underlying architecture. And this doesn't matter if it's an on-premises deployment on infrastructure that you own in your data center to a cloud deployment. We'll talk about some configuration things that you do in Splunk that can have significant performance and capacity implications. We're also going to talk about some design concepts that you can adopt today or wherever you're at in your deployment that can help you scale more effectively over time. I'll show you a quick little thing about how Dell EMC does it internally. So actually, we're a pretty sizable Splunk customer ourselves. We're going to talk a little about use cases, and then we'll show you an easy button, okay? The frank fact of the matter is that we have a problem typically with Splunk architecture and from an infrastructure perspective, and that is that it's often a moving target. So most of you here probably, you're Splunk customers of some size or scale. Most of you probably have a story with Splunk that goes something like this. I got Splunk because I downloaded it on my laptop because it's super cool because I needed to solve a problem, and the tools we had in our team didn't do what Splunk did, so I downloaded it, it was awesome, and then I showed it to my boss that, look at this cool problem I solved, and all of a sudden you bought Splunk, right? And then fast forward 6 months from there, you found all kinds of cool use cases for Splunk. Splunk continued to mature as a software. Holy cow, we can use it for enterprise security and ITSI and all these things, and it just kept growing, and it kept evolving, right? We hear that from a lot of you folks, and we frankly did it ourselves. So it feels like that it's kind of a dark art to do this thing like Splunk architecture sizing the right way. And we love Splunk and their field sales team and their support folks are great, but they oftentimes don't have real strong opinions on hardware and infrastructure best practices. And so what we do is we help try to close that gap. And what I'm going to do is show you today the fundamentals that we use and have been developed over the last really about 4 years that we at Dell EMC have been focused on Splunk as a workload and something that we need to help folks run well. And so what I'm going to share with you is some of those best practices. So things that you can use tactically to have conversations in your organization about what should I be doing internally, and then also externally with your IT vendors, with Splunk, right, to talk about what's the right way to do this, okay? And so I do want to say, so it is an advanced session, so I'm going to make some assumptions. If you don't know what these are, then we can point you to the right places, but I'm going to assume that you have a general understanding of the Splunk platform, right? You know what it is, you know the use cases, you know that stuff, I don't have to explain it to you. I'm also going to make the assumption that you all know the components of a Splunk deployment that need a particular machine. So obviously you have search heads, indexers do most of the work, you have forwarders, and then you have some other servers that do things like license master, deployment master, those kind of things. I'm going to assume you guys know generally what those machine profiles are. If you don't, then you can go to the docs and read it pretty quickly. Another thing I'm going to assume is that you understand that Splunk does data tiering, so hot, warm, cold, and frozen, and that you understand what you need there. And we'll talk about these in a bit, but not too much. But I do want to say this up front. What you're going to hear today, 90% of it is based on empirical data from things that we've done in our labs, from things we've collected from our customers, testing and benchmarking that we've done jointly with Splunk. 10% of it, I'll say, is experience, right? It's just being out there talking with customers, going through deployments, hitting roadblocks, having problems, fixing them. And I will say this, I will say things here that I'm guessing any one of you in the room could say, no, there's a time when that's not right, buddy. And I'll say, you're right, there's always caveats. So this is not gonna be 100% right every time. The intention is to give you some fundamentals that are best practices that'll help you get down the right path and make it easier for you so that if you can find that little thing where I'm wrong, great. Just don't try to throw stones at me if I say something you totally disagree with. Just take it as directional, okay? All right, so one of the things that we know about Splunk is that it gets big fast. Most of you, like we talked about the origin story, right? Starts small, it grows really quickly as use cases grow. One of the things that happens from an infrastructure perspective is that you typically need to grow Splunk for one of two reasons. One, I need it to be more performant, or two, I simply need more capacity. So the things that drive performance requirements would be things like, I'm ingesting more data, right? Real simply, I need more indexers to handle the load, or it might be things like, hey, I want more search performance. My searches aren't happening as quickly as I want. I've added users, or really specifically, it's the premium apps. Specifically the apps that you need to be aware of, and we're gonna talk about this in detail. Things like enterprise security, ITSI, the VMware app, user behavior analytics, and even the machine learning toolkit to an extent. These applications, when deployed, have massive impacts on your indexer environment. The reason why is because out of the box, those apps do things, package searches, and data model acceleration that happens just by their deployment that you need to account for in your sizing. And if you don't, then it can cause performance challenges pretty quickly. Capacity is the same thing. As I'm growing my environment, as I want to keep data for longer, right, I want to retain data for a longer period of time, or I'm doing things like I'm going from a distributed to a clustered environment, those things drive pretty significant capacity increases. And the premium apps not only drive performance constraints, but they can also challenge you from a capacity perspective. So if any of you have gone through any like the ITSI or ES sessions, you've seen things like data model acceleration, that can have not only a small percentage increase in storage consumption, it can actually have up to an 8x storage overhead, depending upon the data model acceleration you enable. You gotta account for those kind of things. You don't always plan for 8x, but you gotta be aware that storage consumption can happen just by deploying applications. Okay, so from a sizing perspective, I'm gonna start with first, how many servers do I need, right? How many machines am I gonna have and what's their profile? And then we'll get into how do I figure out what's the storage, whether it's in the server or whether they're gonna use externally attached storage. We'll talk about how you actually size those. So let's start with servers. First, Splunk published, and I'm really thankful for this because we've been friendly arguing and discoursing over, Splunk, would you please have an opinion besides a 12-core, 12 gig RAM box with 800 IO? Like, no, that's very few people actually deploy that. It's a base reference hardware. Like, would y'all please come out and have a conversation about something better than that? And so they published these over the last year, and it's exciting because now we have an opinion, right? Splunk said, hey, a mid-range server, that's a pretty good place to start, and frankly is more aligned to the way server vendors like Dell are manufacturing servers, is 24-core box with 64 gigs of RAM. And still they say at least on 800 IO, I will argue this, I think you should use 100 IO per core is a generally good rule of thumb, right? Every core that you're gonna put in an indexer should have 100 IO capable disk storage attached, or flash. And then the high performance one is a 48-core box, right? That's a big beefy server, more RAM, and they like SSD in this case. So if you want the best performing environment, Splunk is now coming out and saying, you need to invest in more cores, and you should definitely invest in things like solid state drives. Right, the performance that we can drive from solid state is impressive, and what Splunk has done since 6.5 is continue to basically re-architect how Splunk works under the covers, that they can actually take advantage of these beefier servers, right? They can actually use more cores, they can use multi-core more effectively, so actually getting these bigger boxes can help, okay? So these are the indexer reference requirements, and remember the indexers, they're the ones that do the heavy lifting, right? They're the ones that do the most work, so these are the ones that we really try to size first. Because if you get your indexer cluster right, everything else will kind of generally fall in line behind it, but you gotta get this part right. Okay, then there's some other servers that you're gonna need, other machines. You will potentially need, obviously, search heads if you're doing more than a single instance deployment. They just published at 16 cores, 12 gigs of RAM, and you don't need nearly as much disk, right? So it's gonna be more RAM intensive. Cores, you know, you need, generally that's the minimum. I still like, you know, using the mid-range is a pretty good place to start. Then you need other servers. So you need things like heavy forwarders, utility servers like License Master and others. Those can be much lighter weight in terms of core requirements. What I will generally say too is all of this can be virtualized. It's actually been validated by Splunk, just designed for it, and we'll talk about it in a second. But Specifically, what's really popular to virtualize is basically everything on this bottom row, right? Some people still want to run bare metal, physical servers for indexers. Okay. Virtualize everything else. It's way easier from a management perspective. Okay. And this is the dark truth. So when you make a decision, if you're not going to virtualize, whatever you start with is kind of what you're going to have to own for a while. So currently, when you deploy Splunk, if you have an indexer cluster, those machines need to be parallel in terms of their core counts, their memory densities, right? You need that level set. So whatever you buy up front, what you start with, is kind of what you're going to run with for a while until you just decide to do a replatform. So make sure that you choose wisely up front. That's again why we like to say buy as good a platform as you can up front when you start to deploy Splunk. Okay, so those are the machines we know we need to have. Now, how many of them do I need? So the way we back into the number that we need is starting with the indexers. We, Dell EMC and Splunk's professional services team, have published these opinions in various cases, but I will say them here again. If you're using, the way this is set up is on the left, you've got the minimum reference hardware, the middle is the mid-range, and the far right for you guys is the high performance. We figured out that there's an amount of volume of index per day per indexer that makes sense. So if you buy the low end, you build the minimum 12-core, 12-gig box, you can handle up to 250 gigabytes per day of ingest, okay? Now that is assuming that you're not running those big apps that we talked about before, like enterprise security, UBA, ITSI. If you choose to run those apps, the gray box is your ingest volume. And what you'll find there is that if you run that base reference hardware, the minimum, you can only assume 40 gigs per day per indexer if you're running ES. It's not a lot. The reason why is because either one of those apps, any of them, create a bunch of work in the background for the indexers to do, so they can't handle nearly as much volume on the front end, okay? So if you are going to virtualize this, do not oversubscribe vCPUs to CPU. Like, make 1-to-1 in terms of CPU ratio, vCPU ratio needs to be 1-to-1. Hyper-threading, don't assume it in your core counts, but turn it on, because you do get benefits specifically for virtualizing. And if you don't know, like you don't know how, if you're just sizing something out of the box, use 100 gig per day, regardless, and you'll get kind of close, right? If you just don't know what you're doing. Okay, so then the mid-range, you can obviously see if I buy that bigger, beefier box, I can handle more index volume. So I can handle up to 300 gigs per day if I'm doing none of the apps, and I can handle around 80 gigs per day on the mid-range box if I'm doing ES. And then if you get that big 48-core box, again, we still don't want to do more than 300 gigs per day with no ES, but you can assume up to about 100 gigs per day per indexer. So the math here is basically simple. It's like, hey, I have a terabyte per day ingest of Splunk. How many, and I'm not running enterprise security, how many servers do I need for indexers? Well, if it's this one, 250, 1 terabyte divided by 250, that's 4. 4, that's how many indexers I need. If I'm turning on ES and I'm doing a terabyte, I need a lot more than that because I can only get 40 gig per day per indexer. Make sense? So this is a basic fundamental, right? You say, what's my Splunk license? What am I ingesting? And then you figure out what the volume is per day based on the apps you're using, and that's the number of indexers you should start with. It's a good rule of thumb. If you're trying to get it up and running today, you're just buying it for the first time, use that, okay? On the search head side, generally what we talk about is when you break them out and dedicate them, and when you go from a single instance deployment to a distributed deployment, we typically say like a 1-to-8 ratio is kind of a good place to start, meaning 1 search head per 8 indexers. And the interesting thing that we found, or you can use this table, and this is from Splunk's docs. The table tells you based on number of users and concurrent searches you're going to run how many search heads you might want. But I will say this is one thing that we found interesting when starting to work with Splunk was if a customer like you guys go and say, hey, my search performance is not awesome, the first thing they're going to tell you is actually add indexers. Indexers have a bigger impact on search performance than search heads do in many cases. So be aware of that. Search heads, they're important, but the indexers do the heavy lifting. So then you've got the ratios, you can figure out how many search heads you need. Then you're going to need some other servers. So we use a 3-to-1 ratio, meaning for every 3 servers that are indexers and search heads, I should probably add another one of those lightweight boxes for things like heavy forwarder, license master, distributed management console, cluster master, those kind of things. And again, great opportunities for virtualization here. So again, this is the how many servers do I need. So now you've just been given the tools to say how many servers should I build in my index cluster and my search head and my heavy forwarders. You can now go buy all the servers you need. Pretty cool, right? You could also use the same thing to have a conversation with a cloud provider. If you choose to deploy this in the cloud, this guidance will generally get you down the right path on the number of machines you're going to need to run Splunk effectively. Make sense? Okay, now shifting gears, storage. Storage is kind of a big deal. You need a lot of storage, and if any of you are running Splunk at, let's say, north of 500 gigs per day, and you're keeping data for any amount of time, you notice that it builds up pretty quick. And Splunk has absolutely become a mission-critical application, and I have a number of customers that Splunk is now consuming more hardware and infrastructure in their data centers than many of their mission-critical apps are. So it becomes a big deal. So we got to figure out how much storage we need. And storage is actually kind of a weird one to size, but we're going to pull the covers back. So hot and warm tiering always need to be, they always stay together. You can't separate them from one another. Cold, we are allowed to actually separate that and put it somewhere else, right? And they do that intentionally because Splunk realizes that not all value is equally valuable or needed for search, but you still may need it, so you can, but they want to help you optimize your cost per terabyte over time, so you might choose a different platform for cold than you would for your hot and warm storage because it's unlikely, or I should say it's less likely that you're going to be running searches against it, okay? So with hot and warm, the only storage platforms that are supported are either direct attached disks in a server, right? You can run drives in a server, or you can run SAN. So block attached storage works, or things like software defined SAN are acceptable here. You do not ever run a NAS for your hot and warm, because if you're running a NAS, protocol latency and basically just NFS will make Splunk puke all over itself, so please don't do it. If anybody recommends it, tell them they're crazy, and most Splunkers here would totally back me up on that because we've had problems where people have tried to do it. You get all kinds of corruption, NAS latency, no bueno for hot and warm. But for cold, it's awesome because NAS, typically NAS platforms as a cost per terabyte are typically cheaper than SAN technology, right? So you can optimize your storage cost by using a NAS for cold, but do not use it for hot. Does that make sense? And then frozen, you know, frozen's an option, right? You can use pretty much anything for frozen. You can use object stores, you can use NAS, you can use whatever you want, but frozen's no longer searchable, which kind of sucks, right? It's like, man, I got all this data, I got rid of it. Like, most of the reason why people do it is because of typically legal requirements, right? I have to keep this data for some amount of time, but I don't think I'm gonna ever search it, so just put it over here in frozen. So if any lawyer calls, I can say, no, I still got it, it's over there. But generally speaking, what we find is the big apps like machine learning, ES, UBA, anything that's using machine learning under the covers actually gets better if you keep more data available over time because those models get easier to train for that longer distance tail, right? So that's kind of cool. We like cold. Make cold bigger. Don't go to frozen if you can help it, okay? And then one quick thing. Everybody talks about, you know, oh, I'm gonna keep 30 days in my hot buckets and my hot and warm buckets. I'm gonna keep 90 days on cold. Buckets aren't actually sized by days. Most of you Splunkers who have ever looked at an indexes.conf file, you know that there's no value for days, right? It's number of buckets, size of buckets. So anyways, it's just a fun myth that when people are like, oh, where do I put the day thing? I'm like, that's not a real thing. that's an idea. That's how we like back into the number, because if you know your ingest volume per day, and you know how many days you want to keep, you can generally figure out how many buckets you need. Okay. There is a handy dandy tool that's not officially supported by Splunk. It's like Splunk sizing app spot. I don't know, you can find it. It's pretty handy. Anyways, that's a quick myth. So you have a couple options that are going to impact your storage when you start thinking about indexers. Again, indexers they're the place where you're going to spend your money on storage. Okay, so you're either going to get a distributed deployment or a clustered deployment. So clustering meaning I'm going to allow Splunk to make copies of my index data for the purpose of high availability and disaster recovery purposes. You can either do it in the site, so in site A, I'm going to have a replication factor and search factor copies of data here, and you can instantiate multi-site clustering, where you can have copies of the data that was ingested in one site be copied by Splunk to another site. Obviously, every time I copy data, it's going to add up my storage, right? So we'll talk about that in detail. So distributed deployments, these are typically very popular in environments where, one, it's just kind of like we just got started, right? We're just trying to figure this thing out. We don't have a mission-critical workload yet on Splunk, and so if we lose the data, we lose the data. It's kind of this edge use case. Or, more commonly what I find is people are like, well, I just don't have enough storage to do clustering, so we don't do it, right? And that stinks, right? So we want to help you figure that out. So distributed deployments, the way you calculate storage is pretty darn easy. What you do is you basically say, what's my ingest volume? And you cut it in half. So under the covers, what does Splunk actually do? Well, Splunk takes that terabyte of data that's ingested into an indexer, and it writes two distinct sort of sets of data. You get the raw data, which ends up getting highly compressed, and then you get the indexes, right, the TSIDX files. Those are uncompressed, but they take up about 70% of what gets written to disk. But overall, generally speaking, what Splunk writes to disk will be about half the amount was ingested, right, generally speaking, right? If you have a terabyte per day coming in, generally speaking, you will consume 500 gigs per day on disk. Make sense? Okay, so the way you calculate how much storage you need is, again, back to that days thing. You take your daily ingest, cut it in half, and then multiply it times retention. That'll get you generally close. That's not hard math, right? Okay, so in this scenario, if I've got a terabyte a day and I want to keep data for 60 days, rough and tough, I need 30 terabytes of usable storage. You take that number and then work with your storage vendor of choice, use their best practices in terms of things like, you don't run storage systems ever full, right? There's best practices where you don't want to overutilize stuff. So just use that as your minimum usable config, okay? One other thing I'll say there is I always add 20% to storage overhead because things like data model acceleration, and God forbid you take a snapshot and it consumes space, like prepare for it. So that's called the engineer's cover, right? Okay, so then the next is this concept of clustering, which means, again, I'm using data is being forwarded to my index environment. Whichever indexer gets it, it actually makes a copy of that data. Interesting story, when Splunk, if you turn on clustering to begin with, what's weird is they don't actually make perfect copies of the data. Like the data doesn't get just from indexer 1 to indexer 2, it just kind of sprays it. It's really interesting. What we found out was deduplication doesn't really work that good because of the way that Splunk writes the data and their compression. You don't get a ton of savings from dedupe. So clustering is the way you get high availability for your indexes, and it's controlled by this thing called a replication factor and a search factor. Replication factor manages the number of copies of the raw data that I'm going to keep, and the search factor it tells me how many copies of my indexes I will have, and replication factor always has to be greater than or equal to search factor, okay? So again, indexes are controlled by rep factor, raw data are controlled by rep factor, indexes are handled by search factor. So a terabyte of data ingested, if I'm using an SF and an RF of 2, I'm going to write that 500 gigs that we talked about before, but I'm also going to be replicating that because I've got a search factor and a rep factor of 2, so I've now doubled my storage requirements, okay? So you can figure out the math, it's pretty simple. If I turn it on to 2, I'm doubling my storage. If I turn them both up to 3, then I'm tripling my storage, okay? This starts to get interesting from a storage sizing perspective. Then we have multi-site indexer clustering, which is I'm now going to take data I may be doing an RF and an SF locally, but I'm also going to keep copies of the data at a secondary site. You have to account for those as well when you're building your clusters. So these things can add up. Again, the unofficial tool is your friend here. Again, it's not officially supported. Nobody from Splunk's going to be like, that thing's 100% right every time. It's handy. That's what this session's about, is handy stuff, right? The link is there in the slides, and they should be available in the PDF. We use this thing a ton because it gets me directional, right? I can mess with things like the search factor and rep factor. It has radio buttons that say, like, hey, if I'm turning on enterprise security, it drops the amount of volume that you can do per indexer automatically. You can fool with that stuff if you want. Again, it's a pretty handy tool. The questions you'll need to answer for yourself before using that tool are these. This is really meant to guide you on what you need to collect about your environments, what requirements you need to gather, which is what's my total ingest volume, right, per day? What are my retention periods by tier, right? So how much data do I want to keep in hot and warm for that high performance search environment, and how much for cold? Interesting fact, at the tech sessions or the Splunk Partner Summit they did earlier this year, they talked about, Splunk did a study of their, I can't remember how many customers it was, but they found that 95% of all Splunk searches hit data that was indexed in the last 7 days. So that shouldn't surprise anybody, but that helps me understand, like, if I'm buying hardware and I'm having a size for my hot and warm, I probably need to spend the money to get at least 7 days on there, but over that, probably not getting that much return on my investment, okay? So you also need to know things like, are you doing indexer clustering, and what are those settings? Because those will, again, impact the storage consumption. And are you doing a clustered or indexed, and then single site or multi-site, and then are you doing premium apps? If you can answer those questions, you can use these tools or use our teams. You can build about 95% of Splunk configs you'll ever need for infrastructure. You can do the same thing again with on-premises, conversations with your IT vendors or cloud vendors. This thing will help you. Just straight questions. This shouldn't be new to anybody. Okay. So we at Dell EMC and our Converged Platforms and Solutions divisions where I work, our job is to simplify all this stuff. So instead of you all having to know every bit of this, you probably would want to work with a trusted IT provider, somebody like Dell EMC. We've got the biggest portfolio in the industry, right? So why not have us give you some guidance, because we have some pretty strong opinions. What we've done is we've partnered with Splunk. We've almost 2 years into our official strategic alliance with Splunk, and we've actually been doing some testing behind the scenes over the last year and a half that is Splunk validation testing, meaning we bring our platforms into our environment, we bring Splunk and their engineers in, we run their tools, and they validate our designs. We actually announced last week some cool solutions we're going to talk about a little bit. All this stuff comes out of this Ready Solutions organization that I'm part of. Oops, sorry. A little hard to see. Basically, what the Ready Solutions group does is they're nerds like me that are focused on your success with workloads. And so we have a process that we go through of looking at, okay, what are the workloads that are interesting? So Splunk is one, Hadoop, high performance computing, SAP, Microsoft, those kind of things. And we say, okay, in our portfolio of products, this giant portfolio that Dell EMC have now, which ones make sense? Like, what are the one or two things customers should consider first as the best platform? And so then we do a bunch of engineering, testing, and validation. We have a bunch of services. So like for Splunk, for example, we actually have Splunk professional services that can help you deploy Splunk successfully. And we put all that together with a bunch of engineering knowledge and background, or benchmarking tests, and we have 3 classes of products that come out. We have Ready Nodes, Ready Bundles, and Ready Systems. Nodes are a server with some sort of software deployed on top of them. Bundles are a collection of technologies from Dell EMC put together to work for a particular workload like Splunk. And a Ready System is a hyper-converged or a converged appliance. Think about like VxRail, VxRack, VxBlock. It's those technologies with maybe some bundling of other Dell EMC stuff specifically designed for a workload. The specific Splunk solutions we have, the 2 we announced last week, is the Ready Systems for Splunk, VxRack and VxRail. What VxRack and VxRail are is hyper-converged appliances that can do virtualization with VMware, or if with VxRack you can actually do Hyper-V, KVM, or you can run bare metal. It uses software-defined storage for your hot and warm, and if you have long-term storage requirements, Isilon is a scale-out NAS that leads Gartner's Magic Quadrant thing. It's pretty rad, goes to 96 petabytes. You can use that in context of a rack or rail for cold. This is the VxRail and VxRack are the first and only hyper-converged appliances to be validated by Splunk, and they're also the first virtualized appliances ever validated by Splunk. So that's kind of cool. It's validated to meet or exceed Splunk's reference hardware requirements. Pretty cool, right? And then we're going to be announcing here shortly, we're sneak peeking, we're going to have a Ready Bundle. So if you just love to do things on PowerEdge servers or just servers in general, you like direct attached storage, you want to go that route, we want to give you a known good path of the right servers to buy from us. But even if you're going to go physical and you're going to go bare metal on servers for your indexers, if you want to do that, great. Isilon still makes sense to decouple cold, especially if you have those long-term, like you're going to keep more than 100 terabytes of data worth cold. Isilon starts to make sense from a TCO perspective, okay? So a couple of interesting things. So we've got some customers that partner with us. We've got a great logistics leader. Doug Merritt actually talked about it on their Q1 earnings call. We helped them acquire their Splunk licenses, right? So one of the things that many of you may know is Dell EMC is a little bit bigger than Splunk, not trying to be punk, but like we're a little bit bigger. We have more relationships, meaning customers that haven't ever bought Splunk before probably have bought something Dell EMC. So from an acquisition perspective, we probably have T's and C's already figured out with you. It may be easier to buy your licenses through us. We are a reseller of Splunk licenses. We do that to help simplify the process, right? If you want to buy and replatform, you can buy the licenses and the hardware on one PO and do it as a bundle, because we all know IT projects, you kind of have to account for the whole thing. This puts it all on one bill for you, okay? And we're partnering with these folks pretty heavily. They're actually kicking us in the rear end on some of our apps, and we appreciate it because they wanted to use them more effectively, and they've actually helped us justify some investment in improving those. We've got a great customer. It's a wholesale club retailer that's using some flash technology and Isilon for Splunk, and they're doing it pretty awesome, save some space. They're over 1 petabyte of storage, and it's growing pretty rapidly. And then we're using this stuff. So I don't know if you guys know this, but Dell sells a bunch of stuff online. Many of you have seen Dell.com, right? We kind of sell laptops. I see a few in the room. Well, we actually use Splunk for our e-commerce environment to prepare for Black Friday. Y'all probably know retailers, right? Retailers either in brick and mortar stores or e-stores. It sucks. Like, it is an awful place. It brings out the worst in humanity. It's also hard for systems administrators and site reliability engineers to keep those systems up and running and scale well. And we actually use Splunk to help in our Black Friday prep and then in our monitoring and orchestration along the way. It is our platform of choice. We actually are deploying. We had enterprise deployed for over 3 years. We're now on enterprise security, where ITSI is up now, and we're using it in some interesting ways. So many of you like, web services, e-commerce, that's an easy one. We're also using it for marketing effectiveness. So we're actually doing, when we start to test pictures, images, ads, coupons, those sorts of things on our websites, we're actually using Splunk as the marketing effectiveness tool. So our marketing teams are seeing, the return on investment, which pictures have the best return, those kind of things. We're also using it for security and threat monitoring, so it is actually being adopted as our SIM tool of choice. And we are drinking our own Kool-Aid We had this cobbled together, crappy deployment of Splunk for the last couple of years. And it was literally begged, borrowed, and stolen from various business units. But I think all this gear got shipped a couple weeks ago. We are replatforming on Dell EMC technology. I think it's 44 indexers per site, so decent sized environment, and using Dell EMC technologies, just like we've talked about here today. Now, some of you are Splunk customers and you actually don't care about Dell EMC, but maybe you should. You actually may be running a VMAX or a VNX or an Isilon platform or Stream.io, and we've actually built apps that you can apps and add-ons where you can go Splunk those. So you actually have tech add-ons in Splunk base for those 4 platforms, VNX, VMAX, Stream.io, and Isilon. The Isilon one's kind of cool because it's not just like storage performance. Because it's a NAS, it actually does file system auditing. So you can see who's doing what with what files for the purpose of file system metadata management. Kind of neat. The reason why these apps exist is kind of twofold. One, we wanted to make it easier for those customers that have chosen Splunk as their enterprise monitoring tool for IT ops. Why not be able to use our platforms? We've had customers, I don't know if they're in the room, we had a customer literally told us, like, we don't buy anything that doesn't have a Splunk app, so you better get one. So we had to develop an app because we wanted them to buy our platform. So it's becoming a standard, and so we get it, and we want to be supportive of that. I will say this, if you're in IT ops, the interesting thing about these apps, it's out of the box. It's literally the add-on goes and gets the data logically from the platform, and the apps out of the box give you storage performance reporting. It's a good starting point. It's not perfect, but here's the thing for you as Splunk users. It's a starting point that you can start to understand storage as part of a larger IT service. Right, so what we're trying to make it easier for you to do is if you're using ITSI and you want to look at the complete stack of infrastructure monitoring that's needed to support that particular service, we're trying to make it easier for you to integrate our platforms into that view. Okay? This is going to improve over time. We're actually talking about ITSI certifications for all these apps as well in the future, but I highly encourage you to check them out because guess what? They're free. I feel like Oprah. You're getting an app, you're getting an app, you're getting an app. Okay. All right, cool. We also have global solution centers. If you don't believe a thing I said today and you want to see this stuff run in real life in a lab, we have them around the world, and we're happy to do everything from if you want to have an architecture chat about what's the right way to do this, or you want to run a POC, or you need to see this gear and get the fans to blow in your beard like me, you can come to our solution centers and we're happy to help. The folks who we will engage in those solution centers are our Splunk Ninjas. As I said, we've got a team of ninjas around the world that are Splunk SC trained that can come have a seat at the table with you to talk about what's the right way to build Splunk infrastructure. These folks know Splunk because they've been trained by Splunk, but they know our portfolio as well, and they're religious about following best practices because we don't want you to fail. We want you to be successful. I will ask you this, rate the app. If you have questions, I'm more than happy to answer them. Definitely stop by the booth and check out some of the cool stuff we're doing. Thank y'all. Any questions?